Okay, when we do problems like one was asked here was a plus bi raised to the sixth power, the reason why we do some of these problems are multiple. Among the best answer to give why we do some is to practice our distribution skills and attention to detail when distributing a bunch of numbers and factoring out numbers. And that in the end will help us with our other math work. So let's go ahead and start attacking this. So the way to think of this problem that might make it easier is as if we could say that a plus bi to the sixth would be a plus bi squared all raised to the third power. And if we do that, we can go ahead and maybe see how we could build those individual problems, which is a plus bi quantity squared, and solve that and then build it by cubing it. So let's go ahead and start that procedure. So I'm going to go ahead and on the side here look at what a plus bi squared would be. And when I go ahead and solve that, I want to just think of my factoring pattern that we learned in Algebra 1, a plus b quantity squared. So let's just go ahead and fill this out. And as we think of the terms, we'll see that we want to bring and put the real terms first and then the imaginary terms second. So I know that I'll have an a squared. And then if I think of the center term, we'll kind of think of that last because that's going to be the imaginary term. Now if I take the last term and see it's b times I quantity squared, that becomes a negative b squared. And then I finish this off looking like this. And this then becomes the real term. This is the imaginary term. And now I know what a plus bi quantity squared is. So if I go ahead and rewrite this number as the quantity of a minus b, a squared minus b squared, plus 2ab I, then squared, because that is like saying a plus bi squared squared. And that takes care of two of these. And then the last one is just going to be then, again, a plus bi squared, which we know what it is. And it's going to be a squared minus b squared plus 2abi. Okay, so now we've taken care of that. Let's go ahead and attack this first part by, again, doing the a plus b quantity squared idea. So I'm going to go ahead and this is my a. So I've got a squared minus b squared, and that's going to be squared. And notice this times this is going to be my imaginary term, so I'm going to leave that to the end. So the next thing I'm going to do is I'm going to square this. And this would be 4a squared b squared I squared, so it's going to be minus 4a squared b squared. Notice the I squared turns into the negative 1. And then I'm going to add the 2 times my a. And notice I'm talking about an a now from Algebra 1, and then a b, which is from Algebra 1. It might seem confusing, but this is my 2ab, because b is that, and here's my I. Okay, and that's how that will distribute out. You just memorizing our factoring patterns. So that is that imaginary number, I'm sorry, complex number squared. And then we have it here next as this factor, a squared minus b squared plus 2abi. Okay, now let's just go ahead and clean this up a little bit because I could just go ahead and bring this 4 here. And I'm going to distribute this, and we're going to clean this one up. So let's watch that. Okay, so I'm going to go ahead and distribute this and mark this as a to the fourth minus 2a squared b squared plus b to the fourth minus 4a squared b squared plus, I'm just going to leave this factored and just put the 4 together. 4ab a squared minus b squared. I didn't do that for any particular reason. I just kind of felt like it. And that's there. And then let's write our a squared minus b squared plus 2abi. And finally, I could look at this, and this had been our homework for the other night. I'm going to drift these equal signs a little bit to the left just so I have enough room. I'm looking at my terms now, and I notice I have a to the fourth, b to the fourth. Nothing changes there. So I'm going to bring this here. And I have a negative 2a squared b squared and a negative 4a squared b squared. So I'm going to combine those to be minus 6a squared b squared plus my imaginary term, which is 4ab times the quantity a squared minus b squared times I. I can group that, and then I have my last factor, the real part being a squared minus b squared, and the imaginary part being 2abi. Okay, so now we sit back and we say, well, what's left? We just have to distribute these two together, and then we'll have our final answer, which is a plus bi to the sixth. So what I want to do is I still want to consider this a real term, and I want to take it times all the real terms here, and I think that'll be easier first, so let's do that. Let's take this real term times each of these, so I have a to the fourth times my real term. I have b to the fourth times my real term. I have minus 6a squared b squared times my real term. Sounds redundant, but good organization now. I've taken care of that distributing. Now I notice that this imaginary times this imaginary will result in a real term. So I'm going to examine it ahead of time. You notice I have 4, 2, AB, so I'll get 8a squared b squared. I'll have this factor, a squared minus b squared there, and the I squared turns into a negative. So I'm just going to write minus, and this is going to be 8a squared b squared times a squared minus b squared. That takes care of that. So the last thing I have to do is take care of my imaginary terms. So that's my real. And then I'm going to add my imaginary terms next. And what they'll be is just, I'll take this times this. And notice if I have this times this, I'll have a this is an a squared minus b squared. Here's an a squared minus b squared factor, and so that'll be just that factor squared. And so this will turn into 4. Again, this is, remember, this is going to be an imaginary part, so I might as well group it now because I'm having I at the end. So I'm going to put 4ab quantity a squared minus b squared squared. And then if I multiply this one times these two real terms, this real term, which is composed of 3 terms, I will get, let's just write that so we don't confuse it. Let's go ahead and write, hopefully we have enough room here, a to the fourth plus b to the fourth minus 6a squared b squared times 2ab group, and then let's group this and put an I. And that is one huge problem so far. So, well, let's use the whole room of the paper now because I think we're going to need it all in this one to start distributing. This is turning into a mega problem. We're at 10 minutes already. So I'm just going to start distributing and see what I have here. Let's see, I'm going to have an a to the 6th, and I'll have an a to the 4th b squared, and I'll have an a squared b to the 4th, b to the 6th. If I distribute this, I'll get an a to the 4th b squared. So I'm going to do that because I'm going to get an a to the 4th b squared here. So let's start doing that. Okay, so I see a reason why we want to combine things. Okay, so it's going to all happen. So I'm just going to go ahead and write a to the 6th minus a to the 4th b squared plus, and I'm going to organize by putting a first. So I'm going to rewrite this one now, a squared b to the 4th, and then minus b to the 6th. So let's double check. That term's there, that term's there. Then I have a plus a squared b to the 4th minus b to the 6th. I'm going to distribute this, and I get minus 6 a to the 4th b squared. And then I get a plus 6 a squared b to the 4th. And then now here I get a minus 8 a to the 4th b squared plus 8 a squared b to the 4th. And that is my real part. Now in here, I don't know if I have even enough room to put in my imaginary part. So I'm going to, I think, clean this up first and then start attacking this because I really don't have the room. And if we were going to do this, maybe off video, I might then do this on another piece of paper again, do that as a separate problem, and then bring it in. So that's kind of what the philosophy I'm going to do here. So I'm going to say plus, I'll just zoop something in I and just let that sit for now. And let's go ahead and clean up this real part here. Let's see what we have here. Of terms that I have to the 6th power, I have a to the 6th minus b to the 6th. That takes care of these two terms. Now, let's see how many a to the 4th b squared do I have, or a squared b to the 4th. Let's attack the a squared b to the 4th. There I have an a squared b to the 4th. There I have an a squared b to the 4th. So I have one of them here. I have 6 of them here. And then I have 8 of them here. That's what I see. 1, 6, and 8. So I'm going to put check mark here, and check mark here. 1, 6, and 8. 1, 6, and 8 is 15 of them. Plus 15 a squared b to the 4th. Okay, so now I look at how many a to the 4th b squareds do I have. And I have negative 1, negative 6, and negative 8. So I have minus 15 a to the 4th b squareds. And that then takes care of, okay, if I check that one, that one, that one. Let's see, does every term have a check mark? Yes, it does. And look at how nice that cleaned up. So I'm done with my real part, and I think I'm going to leave it like that. I don't see a factoring pattern. Maybe there is one, but I really don't see it right now. So I'm going to attack this imaginary part now. So if I were going to go ahead and do that, let's see what I would do. I'm going to kind of think. I'm going to rewrite this one, and I'm going to, I really would just, I'm so used to making a work zone. I want to do a work zone. And I guess my work zone is just going to be part of the problem. So let's just attack it. So I'm going to say plus, and I'm going to put a big bracket here just so I could keep track of my imaginary part. So my first one is going to be 4ab times a squared, a to the 4th, a minus b squared, a to the 4th minus 2a squared, b squared, plus b to the 4th, and that's that first one. And this one seems pretty easy. This is just going to be plus 2 a to the fifth b. 2 a to the fifth b. That's if I distribute that one. And then I'm going to distribute this 2a b to the fifth plus 2a b to the fifth. That's that one. And then finally, my third one is going to be minus 6 and I'm sorry, minus 12. Oops, icky. Now that's why I don't like to write in ink all the time, because I made a mistake there and now I have to go ahead and just write over it. Minus 12 a cubed b cubed, a cubed b cubed. And that's the end of our imaginary, so I think I'm going to do this. And I still have to distribute this because, let's see, I'm going to get an a to the fifth here with a b, and here I have an a to the fifth with a b. So I still have one more bit of distributing to do. And what I'm going to do is, so I'm going to make myself a mini work zone. This is a mini work zone here right now. So I'm just going to go a mini work zone and distribute this, because this would be 4 a to the fifth b minus 8a cubed b cubed, okay, plus 4ab to the fifth plus 2a to the fifth b plus 2ab to the fifth minus 12a cubed b cubed. And there's my mini work zone. Let's see. So what do I have? I'm looking for terms now. I have 4 of these, 2 of these on a to the fifths. So I'm looking for my smallest a, and here's a 1a to the fifth. Here's a b to the fifth. There's another a b to the fifth. So I've got some common terms. I think I'm ready to be done. Remember, this is all in I terms, so let's finish our right answer. So we're going to say the real part is a to the sixth minus b to the sixth plus 15 a squared b to the fourth minus 15 a to the fourth b squared. That is my real part. So I'm going to show that by grouping it. And I did go ahead now and plus my imaginary part. So what order I do this, I'm just going to be systematic here. I'm going to take anything a to the first power. So when I have a to the first power, I see I have b to the fifth power. So I've got 6 of them. So plus, okay, 6a b to the fifth power. And then that takes care of that one and that one. Next one are going to be the cubes. I've got a negative 8 and a negative 12 minus 20 a cubed b cubed. There's that one and that one. And finally, the last ones left are 6 plus 6a to the fifth b times I. And there we have it. Now, what we're going to do is I'm going to go off camera. This has taken a wonderful 18 minutes so far. There we have that. And I'm going to go off camera and see if I could figure out with my graphing calculator how to check that with a numerical problem where we do something very simple with a and b, and we'll plug the numbers in and see if we get the right answer. We'll be back in a second. Okay, we're going to go ahead and check our work by letting a equal 2 and b equals 3. So what we'll do then is we will go to our calculator, and we want to go ahead and select the mode. So let me bring the calculator in here and let's take a look at it. So hit mode, and let's go from real mode to a plus bi mode. So we hit enter there. And so let's go to our home screen and let's figure out what a plus bi to the sixth power is. So I'm going to say 2 plus 3, and second period is the I symbol. So we'll group that. We'll raise it to the sixth power. And if we did our work right, This would be 2 plus 3I to the 6th power should be equal to 2035 minus 828I. Let's check our work now. We'll do it in the calculator step by step here. So I'm going to now put 2 raised to the 6th power minus 3 raised to the 6th power plus 15 times 2 squared times 3 to the 4th power minus 15 times 2 raised to the 4th power times 3 squared, and we hit enter and we get 2035. So this checks here. So this is 2035. And let's check our imaginary part now. And our imaginary part would be 6 times 2 times 3 to the 5th power minus 20 times 2 raised to the 3rd power times 3 raised to the 3rd power plus 6 times 2 raised to the 5th power times 3. And we hit enter and we get a negative 828, which fits our answer here, negative 828. And so presto, we have now checked all our work and it's valid. We could be happy. And granted, it was a long problem with explanation, took 20 minutes, but actually we'd find if we might sit down and do this, it would take something less. And we've checked our work and we're happy, and let's go celebrate. Have a good one. Bye.